Hi guys, today is April 23rd, Friday, and as majority rules, you guys voted for how we wanted to do class after spring break, and it was, you like the live classes, which so do I, unless class falls on a Friday, then you preferred to have the pre-recorded videos, because apparently I like still hold you accountable for Friday. But yes, so here's your pre-recorded video for Friday's lesson. Today, we are starting something brand new. You've never seen it before. And it's really kind of the last thing that you need in algebra before you go into high school, and that is quadratics. So how can I identify key features of the graph of the quadratic parent function? So topic 8, which is what we are starting today, is all about quadratic functions. And then topic 9, which we'll do afterwards, is about quadratic equations. So quadratic functions, quadratic equations, and then we're done. And then you take your end of course exam. So very similar to what we did at the end of first semester. We had that big giant test. We'll have that again at the end of this semester. Quadratics will be the last thing that's on it. So let's go ahead, without further ado, get started. I love quadratics. You guys will hear my quadratic song later. And it's the best ever. Some of my students still remember the quadratic formula. And I'm talking like some of my kids that are like 23, 24 that had my algebra class. Quadratics, the best. All right, so a quadratic parent function. Remember when we started with absolute value functions, exponential functions, there's always that parent function. So that's the one that, like, it's not transformed, it doesn't go up, it doesn't go down, it doesn't strengthen or widen or shrink or anything like that. It's just the straight parent function. And a quadratic parent function is simply f of x is equal to x squared. Okay, if you have your book, and I'm going to leave it kind of big like this because the book actually does a good job of explaining this stuff. We are on page 315 if you do have your textbook and want to follow along. Okay, so page 315. But what the quadratic parent function is f of x equals x squared. Okay, so with the exponential functions, our x was our exponent, but with quadratics, it is x squared. So if I were to create a table of this, right, I'm just choosing the same numbers of positive and negatives. If x is -2 times -2 is 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So you'll notice our vertex is at that 0, 0. And then we get this kind of shape. It's not quite a V. Okay? Absolute value didn't have all these little middle ones because it was absolute value. So absolute value went 1, 1, 2, 2, 3, 3, 4, 4, right? And so it was a straight V. But a quadratic does not have those straight lines because it's got all of the ones in between as well. So a quadratic is like this, kind of like a U-shaped almost. This is called a parabola. Now that I've said that word, you're going to hear it 1,000 times with quadratics. Quadratics will always create a parabola. The parabola can open up, it can open down, just like absolute value. It can shrink, it can compress, it can do all the things that a vertical or that an absolute value one did, only it's not straight. It is curved like the exponential. So think you're combining absolute value with exponential, that gets you quadratic. Okay, so they're kind of like that curve. Well, it's pretty easy to see that obviously, no matter if it's positive or negative, it's always going to end up being a positive at the end because it's squared. And whenever we square a number, even if you get 2 negatives, you get a positive. 2 positives, you get a positive. All right, but we will have negative x values. So if our x value is a negative, we still get a positive y value. It doesn't matter with the parent function. So I ask you guys just to think about this question. When are the values of the parent quadratic function positive and when are they negative? You're just thinking about that for a minute. When are they positive and when are they negative? Well, the parent, they're only negative when the x is negative. But what if I were to take the parent function and turn it into f of x equals a negative x squared? What do you think would happen then? going to be negative. It's going to open downwards. It's a little preview to what's coming. But here's everything you need to know about your parent quadratic function. Is the vertex is at 0, 0, or the highest or lowest point on the graph. In this case, it's the lowest point because it opens upward. Parent quadratic, our axis of symmetry, is the y-axis, which means I could fold it in half right on the y-axis, and it would be the exact same on both sides, like a butterfly, right? This is the butterfly's body. These are its wings. They're the exact same. There you go. All right, so now let's actually work with this parent quadratic function a little bit, and let's change things up a bit. So here, let's take a look at this. What happens if we add a number in front of the x? So now we have an ax squared. So if I put a number in front of that x, what happens then with our parabola? Well, it's on here. It's pretty self-explanatory. When you have a number that is greater than 1, like 2, 2 is greater than 1, right? It is actually going to make it smaller, okay? It's actually going to kind of like shrink it a little bit. Which I'm going to show you why in a second. And then if it is less than 1, we're not talking negatives yet, we're talking less than 1, so that would be like 1/3, 1/2, 3/4, things like that. If it's less than 1, but greater than 0 still, it is going to make it wider. Now the reason for that is, like I said, you can always go to the fallback of making tables, right? So if we have 2x squared, so now we've got a number greater than 1. If my x is -2, 0, and 2. We'll just do those ones. Okay, these are my x's and these are my y's. So if I have, what's -2 squared? 4. 4 times 2. Plugging that in, right? That gets me 4. It's going to be 8. So now, when x is a -2, my y is at 8. So it's way over here, which is why it is now wider. Now, if I did a decimal, so let's say this is 1/2. 1/2. What is 1/2 squared? 1/2 times 1/2 is 1/4. 1/4 times 2 is 1/2. So now -2 is going to be, oops, sorry, 1/2, about here. Nope. Nope, I lied. I did that backwards. Dang it. Of course I would because I'm recording it. I did it backwards. Let's do 1 because we can see it on the graph. Backtrack, guys. Backtrack. Okay, let's do 1 so that we can see it. So if my a is greater than 1, 2 times a -1, so -1 times -1 is 1, times 2 is 2. That's still going to be 0 no matter what. And then that's going to be 2. So if x is -1, y is 2 up here. That is what's going to create this one. Now, to green, so if we did 1/2 x squared with the same numbers. Okay, so -1 times a -1 is 1, times a half is a half. That's still 0. 1 times 1 is 1, times a half is a half. So when I plot this, -1 is only going to be at 1/2. So it's going to be this tiny little one. So that's why it gets wider. All right, sorry about that, but we fixed it. So the moral of the story on this one is that we can see here, if it is going to be, if your A is less than 1, it is going to get wider. And if A is greater than 1, it's going to shrink inside. Okay, so if it's less than 1, it gets wider. If it's greater than 1, it gets narrower. Moral of the story. And like I said, as always, fall back to those tables and you will be solid. Okay, now this one's, I don't even need to explain this one. Self-explanatory. It obviously flips when A is a negative. That totally makes sense. But in case it doesn't, okay? Once again, look at this. So if I have x and y, and if I make this a negative 1x squared, so if x is a negative 1 times negative 1 is 1, times a negative 1 is going to be a negative 1. So that's why we get the negative. So if A is a negative, it's going to open downwards. Okay? All right. So before I move on to the next one last time. If A is less than 1, it will get wider. If A is greater than 1, it will get narrower. And if A is a negative, it will open down. So let's go ahead and move to the next example. Sorry about the little mix-up. I was just going too fast. All right, so now we're going to actually look at a quadratic in itself. Over what interval is f of x is equal to 4x squared increasing? It's pretty obvious, guys. When is it increasing? Well, check it out. If you actually plug it in the tables, okay, so if we're saying x is a negative 2 times negative 2 is a positive 4, and 4 times 4 is 16. If x is negative 1 times negative 1 is 1, times 4 is 4, so it's going 16 to 4. So this time it went down. Okay, look at that. When the x's are positive, it's going up. So in this one, 4x squared, when is it increasing? When the x's are positive. So domain and range speaking, it is increasing when the domain is greater than 0, greater than or equal to 0, because it's going to go up at 0. If I were to graph this, I'm not saying that I am, but if I were to graph this, right, we would have 0 as our vertex, negative 1, 4, negative 2, 16 would be like way up there. And we'd get this, and then it would go back up. Okay, so when is it increasing? When our domain is greater than 0. When is it decreasing? When our domain is less than 0. It's going down, and it's going up. And how would we compare that to the parent quadratic function? Well, that is greater than 4. So if A is greater than 1, it is going to get narrower. We're almost done, guys. Parent quadratic is pretty basic. Okay, so rate of change. All right, these ones are going back to like our slope kind of thing. So rate of change is how much it is increasing. So how much is it going up and over, up and over, up and over? Obviously with a quadratic, it's not going to be linear because it's that curved line. But if we are looking at just between certain intervals, then we can calculate the rate of change for certain intervals. So let's go ahead and do that now. All right, so how do the average rates of change for f of x is equal to 0.75x less than 1, so it got wider, and g of x, 1.5x, greater than 1, so it's narrower, compare over the interval where x is greater than or equal to 2, but less than or equal to 4. So now, guys, we're just looking between 2 and 4. So between 2 and 4 on this, I am just comparing this area. Okay, we're just looking there. Well, let's look here. So if we know that x can be 2 and it can be 4, let's plug in those numbers. All right, f of x is equal to 0.75 times 2 squared. I know that 2 squared is 4, times 0.75 is 3. And I know that 4 squared is 16 times 0.75, which is 12. See where they're coming up with these numbers? Hopefully you guys can see it. I can probably move it in a little bit. There you go. You need the equations here. Okay. Now comparing that to this 1.5x. So I can still use my 2 and 4. So if I plug in 2 squared is 4 times 1.5 is 6. 4 squared is 16 times 1.5 is 24. So now we can compare. Hey, you guys talked about throwbacks the other day. I'm going to talk about throwbacks right now. Okay? y2 minus y1 over x2 minus x1. Dun, 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 dun. Where when we plugged in 2, that was our x's, and then we got our y. So that's our first one, and then we got our second one. Throwback, Yeah? All right, so my y2 is 12 minus my y1, which is 3, over my x2, which is 4, minus my x1, which is 2. 12 minus 3 is 9. 4 minus 2 is 2, which gives me 4.5. So the rate of change for the 0.75 one is 4.5. Likewise, we're going to do the same thing with the 1.5. Okay, so x1, y1, x2, y2, plug it in, y2 minus y1 over x2 minus x1, that gives me 9. So if I am comparing, it says, how do the average rates of change compare? Well, if this one's 9 and that one's 4.5, the 1.5's rate of change is twice the amount of the 0.75. Why might that be? Why might this be twice as much as this one? Why is g of x twice as much of it as f of x? Well, look at our a. The a in g of x is twice the a of f of x. Coincidence? I think not. All right, so we're actually gonna practice that real quick. If you guys need to, well, you're gonna have to pause the video, but if you need to rewind it right now, go ahead. But I want you to do that real quick with this one. Okay, so do the same thing I just did. How does the average rate of change for f of x equals negative 0.5x squared and g of x equals negative 1.5 squared over the interval of negative 5 is less than or equal to x, which is less than or equal to negative 2, compare? Hopefully you notice the difference between 0.5 and 1.5, and you can go from there. And hopefully you can tell the answer right away, but if not, do the math. And actually, I want you to do the math regardless. So pause the video right now, because I'm going to go ahead and go over the answer. So pause it, pause it, pause it, pause it. When you are ready when you have it solved, unpause, because I'm going to do the answer. Nope, nope, nope. All right, guys, so here's all of the work for that. Same thing that they just did. So hopefully you noticed that 1.5 is 3 times greater than 0.5, technically less than because they're negatives. And so when you did all the math, you would have seen that the rate of change between f of x was 3.5 between the intervals, and g of x was 10.5 between those intervals. And 3.5 times 3 is 10.5, so it is a third, or 3 times the amount. Good? Get it, got it good. Okie dokie. All right. So this is basically the concept summary. This is overarching. If you're on your video and you want to just kind of screenshot it, go for it. If you don't have your book, but if you have your book, it is the concept summary. So this is the overarching parent quadratic function of everything that you need to know. So f of x is equal to x squared is our parent quadratic function, where our vertex is at 0, 0, our axis of symmetry is the y-axis, and it is opening upward. And then if we are going to compare that to something that is an a of x. So if a is greater than 1, it is going to be narrower. If a is less than 1, it is going to be wider. If a is a negative, it will open down. Good? Good. All right. Now I want you guys to practice on a piece of paper all of these problems. Yeah. I'll go ahead and put up the answers here in a second for you. So freeze it and practice. I'll actually zoom in just a little bit. Can't do a whole ton for you to be able to see everything. There you go. If you can't see the whole thing, it is page 319 in your book. Do your best, but go ahead and pause it because I'm going to start writing the answers down now for you to check your work. Never mind. It's too much to write. Unpause if you're done with the work. And I'm just going to tell you the answers because it's too much to write. So for number 1, the quadratic parent function is f of x is equal to x squared, and you're able to tell the axis of symmetry, the vertex, and how it's going to open. For number 2, if we are comparing these, they're both going to open up, but they're going to be different because it's going to either be narrower or wider, depending on what the A is. For number 3, a conjecture about what does the quadratic parent function include? Why does it include parent? Well, because it's the first one. Parents come before kids. I don't know. That's what I'm thinking. All right, and then number 4, Abby graphed this function. Well, obviously, you guys can find the error right away. The A is a negative, so it should be opening down. All right, and then for number 5, these ones are just asking how is it compared to the parent quadratic function. So for number 5, hopefully you guys are still paying attention. Okay, it should be narrower than the parent quadratic function. Number 6 should be wider. Number 7 should be narrower and it opens down. Number 8 should be wider and it opens down. And number 9, the average rate of change between that interval is going to be 10. The vertex is slightly different though because it is plus 3. So 0, 3, the vertex is going to be it's going to be higher by 3, but the axis of symmetry is still the y-axis. I didn't even know why I grabbed my answer key for that. That was pretty self-explanatory. All right, guys, so you are done for the day. Hopefully before class started, you did your polynomial work from topic 7 review on Savas Realized. And then when we come together next week on Tuesday, before class starts, there will be a quadratic assignment on Savas Realized for you to do before class to review this lesson, and then I'll teach you the next lesson. So hope you guys had a great Friday, and I will see you next week. Bye-bye.